Alright, so I had to make an additional video for number 2 because I changed number 2. So I'm going to go in here and find it and kind of redo that one. I picked a different question that I thought was a little bit better representative of what we covered. And just to be honest, I didn't really like this story problem. So the new number 2 says write the equation of a line that goes through 2 points in each of 3 forms. So I wanted to make sure that you could go back and forth between the forms, because on some standardized tests like the SAT, we don't really know what form they want, so we have to be fluid. So first and foremost, you always need to have the slope. So I'm going to use my mechanism for slope, y2 minus y1 divided by x2 minus x1. Being careful with my math, I get 3 over 4. So this is my m, this is my slope. I think it's easiest to start off in point slope form and then morph into the other 2 forms. So for point slope form, remember, it is y minus y1 equals slope times x minus x1. Now you have a couple different options up here. You could kind of erase this a little bit. You could choose this to be your x1 and this to be your y1, or you could choose this point over here. It really doesn't matter which one you want to use. I always try to use it if there's 2 positives. I'm going to use the 2 positives. So I'm going to use this point. It shouldn't matter either way, but I'm going to use this one. So y subtract 4 equals the slope times x subtract 2. So basically I just took these 2 values and put them in where they go. So that's point slope form. Now to get into slope-intercept form, I need to turn this into y equals mx plus b. So the only thing different really is I need to get rid of parentheses and I need to get y all by itself. So I take the equation from above, just kind of rewriting it down here so I have some room to work, and I'm going to first distribute that 3/4 through there. So you get y minus 4 equals 3/4 x, take away, and you could use your calculator that does fractions, or you could just multiply, and you get 6 over 4, which reduces down to 3/2. I'd rather you not use a decimal here. I'd rather you keep it 3/2, just because you're going to see that more on standardized testing. So I do that, and then my last move to get it in y equals form is I just add 4 to both sides. That way I now have y all by itself, and it's going to be in y equals mx plus b form. Got to kind of be careful over here. A negative 3/2 added to, well, I'm going to rewrite 4. 4 is the same thing as 8/2, 8 over 2. So now they have like denominators, so I can add them together, and I get 5/2. So here is my slope-intercept form. Alright, final move, and also you could have used a calculator to add this up and do it on your calculator. Final move is I'm going to change that into standard form. So let me remember that, because I got to scroll down. 3/4 x plus 5/2. 3/4 x plus 5/2. Y equals 3/4 x plus 5/2. Now the key thing about standard form, remember, it's in the general form ax plus by equals c, and there's basically 3 criteria. Criteria number 1 is no parentheses. Well, we just got rid of parentheses, so we're in good shape. We distributed. The second thing is no fractions. So I'm going to have to show you how to clear the fractions. And then the last criteria is we need to get x and y on the same side, traditionally on the left. Alright, so clearing fractions. Most of the examples I've shown so far, we pretty much just took this number right here, 4, and we multiplied everybody by 4. Now, if there are multiple fractions in your problem, like this one, I see there's a 4 and there's a 2. When there's multiple fractions, basically what you have to do is you have to find the LCM. And if you remember from back in the day, that's the least common multiple. I got to find the least common multiple of 4 and 2, or least common denominator if you want to use that, LCD. I got to find the LCD of 4 and 2, which for this problem is just 4. Both of those numbers go in there. So to clear out fractions, I'm going to multiply everybody by 4. So I'm going to times u by 4, I'm going to times u by 4, and I'm going to times u by 4. And what we end up with is 4y equals, these two cancel, and I have 3x, and 4 times 5 is 20, divided by 2 is 10. And now I'm so close to standard form. You know, I got no parentheses, I got no fractions. Now I just got to get x and y on the same side. So I'm going to move this 3x to the other side. Technically, I'm subtracting 3x from both sides. I usually don't show that, I just kind of move it. So I have negative 3x, a positive 4y, equals 10. The SAT would be happy with this answer, and they would like that answer. Now, some textbooks and some people put an extra criteria on here that says, hey, A must be positive. So if that happens and there's a test and you don't see this as the answer, one thing you could do to make this x term right here positive is you could multiply through by a -1, and that will basically change the sign of everybody. And now I've fulfilled that last criteria that some people put on there to say, hey, the x isn't positive now, or isn't negative, the x value is positive. I don't really care either way. If it's a short answer question, I'll accept both answers. I see the SAT do this a lot. They don't worry about it. So I've kind of been going that route myself. But alright, just a little quick video on the new number 2 because it was different than on the first video that was posted. See you.